We are moving into radicals, and the most common and the most familiar radicals are square roots. Okay, so that is what you have probably heard of before, seen before, and are familiar working with. So you definitely want to make sure you've got your calculator close by, because we're going to be talking about how to do radicals on your calculator as well. So we're going to start with square roots. Okay, we're going to start with square roots. The opposite of squaring a number is taking the square root of a number. Okay? The number b is the square root of a if b squared equals a. So let's do a few of these. So let's talk about what is 1 squared. Good. What's 2 squared? Okay. 3 squared. Good. 4 squared. 5 squared. 25. 6 squared. 7 squared. 8 squared. 9 squared. And 10 squared. Good. Okay. So what I want you to realize is 1 is the square root of 1. 2 is the square root of 4. Okay? 3 is the square root of 9, and so on. Okay? Now we're going to talk about the definition of principal square root. Principal square root. The principal square root of a non-negative number, a, is its non-negative square root. Okay, that means when you take the square root of a positive number, you're always going to get a positive number. So, if I am asking you for the square root of 16, what's the square root of 16? 4. Okay, so 4 is the principal square root of 16. The reason that this is important is because when we start solving and we end up with something like x squared equals 16, these are two different types of equations. Okay? X could be two different things. For x squared equals 16, x could be plus 4 or minus 4. That's different than just taking the square root of 16. The square root of 16 is only the positive value. But when I have x squared equals 16, that's when I need to talk about the positive and the negative. So very often, as we move through this process, if you see something like x squared equals the square root, or x squared equals 3, x is going to be the positive and the negative value of square root of 3. But if I ask you and you see x equals the square root of 3, then we're only talking about the positive value. That's all we're talking about with that. Okay? So I just want you to be aware of this definition of principal square root. Now, you can have a negative 1 outside of the square root, and that's okay. So when you see a negative in front of a square root symbol, that's not a problem at all. All that means is negative 1 times the square root of this value. That's all that means. Okay? Now, we are going to find the square roots of numbers that are what we call perfect squares. Perfect squares. Can I move off this? Are we good? Okay. So here are, all of these are what we call perfect squares. Now, go ahead and grab your calculator. Grab your calculator if you want to. And we're going to talk about how to find the square root of something. Now, I want you to realize the difference between an exact answer and an approximate answer. So everything on this page right here is going to give us what we call an exact answer. An exact answer. They're all real numbers. They're all rational numbers. We can take the square root of every one of these and get an exact value. So on your calculator, I want you to go ahead and I want you to hit the second button and then the x squared button. Okay? Second and x squared. Then, so this is what your screen will look like. Once you hit second and x squared, you're going to have a square root with a parentheses. Okay? Then I want you to type in 49. And what do you need to do after you type in that 49? Close the parentheses. Go ahead and get in that habit. You've got to close the parentheses. So this is what you should type in, and this is what your screen looks like. So what is the square root of 49? Good. Okay. Now, we're going to do the same thing with 25 over 16. We're going to take the square root of that. Now, if you put that in your calculator, you're going to get a decimal. In general, I don't want a decimal unless the problem is a decimal. If you're given a fraction, I want a fraction. Okay? So, what this means right here, this means the square root of 25 over the square root of 16. Now, if you put in your calculator, you're probably going to get 1.25. Okay? But I don't want 1.25. I want 5 over 4. Okay? So I want you to take the square root of 25, and then I want you to take the square root of 16. Question?
No,
You already knew it. Good. Good. And 1.25 is 5 over 4. But you want to get in the habit of giving me the answer in the way the problem was written. And so if I give you a fraction, I want a fraction back, or a whole number. Okay? Now, negative square root of 4, that just means negative 1 times the square root of 4. Negative 1 times the square root of 4. What's the square root of 4? 2. So that means negative 1 times 2, and what's that? Negative 2. Okay. Now I want you to look at this one right here. Do you see how I have given you the problem in decimal form? That means your answer can be in decimal form, but I still want it to be exact. And we know it's going to be exact because the decimal is going to terminate. That means it's going to stop. It's going to fall off. Okay, so I want us to talk about keystrokes again. So your keystroke is going to be second, the x squared button. Okay, then you are going to put in 0.81, and then you've got to close that parentheses. So your screen should look like this, right here. Okay? And what do you get as your answer? 0.9. Okay? Okay. Now for our next one, 9x to the 10th, we know the square root of 9. What's the square root of 9? 3. To find the square root of x to the 10th, I want you to realize that there is an assumed index right here that's a 2. Okay? And we're going to talk about rational exponents a little bit later, but there's an assumed index right there that's 2. So to take the square root of x to the 10th, what you're going to do is you are going to take this 10 and you're going to divide by that 2. What's 10 divided by 2? Good. So that's going to be x to the 5th. Now, I'm going to write this out a little bit different because next week we'll have to do some this way. 9 is just 3 times 3. I'm going to write out x to the 10th. That's x times itself how many times? 10. Okay, so it's going to be x times 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 x. Okay? Now, if you have a set of 2 inside the square root, you pull one of them out. Okay? So, here is a set of 2 3s, so I pull 1 3 out. Here's a set of 2 x's, another set of 2 x's, another set of 2 x's, another set of 2 x's, and another set of 2 x's. Okay, and that is how I get x to the 5th. Now, the more straightforward way to do that is to say 10 divided by 2. That's the exponent, 10 divided by 2. 3 times 3 is 9, but we could also write that as 3 squared. We could write 3 times 3 as 3 squared. 2 divided by 2 is 1, so 3 to the first power. Okay, and that will become a bigger issue next week when we start simplifying radicals. Okay, this next one is just -1 times the square root of 25. What's the square root of 25? Good. So then my answer here is just going to be -5. Now, what is difference between this and this? What's the difference?
The negative is which is 25 instead of outside.
Good. Okay, here our negative is on the outside. Okay, negative on outside. Here our negative is where? Inside. We cannot take the square root of a negative number. So I want you to put this right here in your calculator. Put that right there in your calculator. What do you get?
Domain error.
Domain error. That means that I cannot have a negative value inside the square root. Now eventually we're going to talk about I. We're going to talk about I towards the end of the course. One of the things that you need to understand about I is that I is not a real number. It is an imaginary number, and right now we are only talking about real numbers. Real numbers. So the answer to this right here is no solution or no real number. We will talk about I as an imaginary number later on, but for now, this is no solution. No solution. Okay. Okay, let's move to the next. Now we are going to approximate. When you see the word approximate, that means a rounded decimal is okay. A rounded decimal is okay. If you don't see the word approximate, then I want an exact answer. Okay? So if I had the square root of 5, this right here is an exact answer. Okay? That's an exact answer, square root of 5. If I want the decimal approximation, the word that you are looking for is approximate. Approximate. So that means that we're going to have to round. So what I want you to do now is I want you to put the square root of 5 into your calculator. Put it into your calculator, and then I want you to read off what you get in your calculator. Tell me what you get, and we'll go to 6 decimal spots. Just read to me what's on this screen. 2.236067. Is that right? Okay. So, it goes on forever. This is an irrational number, just like pi and just like e. Okay? The square root of 5 is an irrational number. That means it's a non-repeating and a non-terminating decimal. So what I want to do is we're going to round to 3 decimal spaces. Okay, we're going to round to 3 decimal spaces, or decimals. Okay, so when I round, I am going to round to the 3rd decimal spot right here. This is where I'm looking at. I want to round to the 3rd decimal spot. To round to the 3rd decimal spot, I go right here. I've got to look at that number. If it's 0, 1, 2, 3, or 4, what does that tell the 6 to do? Stay. So then my approximate answer to this is 2.236. That is an approximate answer rounded to 3 decimal spaces. Okay? Okay. Now I want you to do the same thing with 7. Okay? Take the square root of 7 and tell me to 5 or 6 decimal points what you get on your calculator. What do you get? 2 point what? Okay, 2.64575 Okay, and then it kind of keeps on going. So we are rounding to the 3rd decimal spot right here, 3rd decimal spot. So I need to look at what this number is telling this number to do. So does 7 tell the 5 to stay the same or go up? Go up. So then this is approximately, that's what those squiggly lines mean right there, is approximately 2.646. Okay? Now you try the square root of 11 and tell me what you get. Okay, we are rounding to 3 decimal spaces. 3 decimal spaces. What did you get? 3.317. Good. Okay, so on your calculator, you probably got 3.316624. We're rounding to the 3rd decimal spot. Okay, so we're going to look at this 6 telling this 6 what to do. And because this number right here is greater than 5, we take this 6 up to 7. Good. Okay. Now, I want us to look at cube roots. Cube roots. Okay. Cube roots, you've got a 3 right here. Okay, so you're looking for the number multiplied by itself 3 times to give us the number inside the cubed root. Now, cube roots go up super fast, right? They go up really fast. So, if I've got 1 cubed, what's 1 cubed? 1. What's 2 cubed? 3 cubed? 4 cubed? 5 cubed. Yeah. Okay. So, 2 is the cubed root of 8. 4 is the cubed root of 64. And we've worked some with cubes. We have worked some with cubes. One thing I want you to realize is that you have to have a 3 right there for it to be cubed root. If you don't have a 3 right there, then you're talking about a square root. Square root is the only one that doesn't have a number there, and that number is just because we use it so often, and it's an assumed 2. Okay? Now, square roots, like square root of 4, cannot have negative values. But cube roots can. Okay? That is a place that students make mistakes a lot. Okay? This is what we call an index. If that number right there is odd, so 1, 3, 5, 7, 9. If it is odd, negative numbers are okay. If it's even, 2, 4, 6, negative numbers are not okay. Okay? So once we hit cube roots and we start talking about odd indexes right here, it is not restricted to non-negative numbers. Okay? So cube roots, fifth roots, all of that is not restricted. Okay, we're going to have to play around with your calculator a little bit for this one. Okay, so let's, you should have a button on your calculator that you're going to have to hit second. And then above one of your values, you should have something with a little X right here. It looks something like that right there. Okay? Do I have the X and the Y in the right place? Okay. What is that above? The carrot top? It's above the carrot top. Good. Okay, so you're going to hit second carrot top. Okay, you're going to hit second carrot top. And on your screen, you're going to see something that looks like this. And you're going to have like a little flashy thing right here. Do you have that? I might need to see somebody's calculator. I don't think I have one up here. The ones I leave up here. May I see your calculator? Okay, so on your calculator, this right here is going to give you the root symbol. Okay, so you're going to have to hit second and your calculator or the carrot top to get you where you want to go. Now, what you have to do though is you've got to put the 3 in first. So what I want you to do, and we're just practicing right here, I want you to do 3, then second carrot top, then I want you to put the number 8 in. 3, second carrot top, and the number 8. And I was actually surprised that it doesn't give you parentheses, but it doesn't. Now try 3, second carrot top, 125. What do you get? 5. Okay, so make sure you're comfortable with the keystrokes. Make sure you're comfortable with your keystrokes. Okay, so now what I want you to do is I want you to do the cubed root of 27. You may know what the cubed root of 27 is. What's the cubed root of 27? 3. Okay, but practice your keystrokes there. Practice your keystrokes there. You're going to have 3 second cube root 27. Okay, now remember, if I give you a fraction, I want the answer as a fraction. So what you need to do is you need to find the cubed root of 8 and the cubed root of 125 separately. Okay, now those are numbers that we're relatively familiar with. What's the cubed root of 8? What's cubed root of 125? Good. Now, because this is 3, this is an odd number, negatives are okay. Okay, now, keystrokes. You need a 3. You need a second caret top, and then that negative 125 has got to be in parentheses. Okay? 3 second caret top, negative 125. What did you get? Negative 5. Good. Okay. Now, here, I've got the cubed root of negative 8, x to the 9th. We know how to find this right here. What's the cubed root of negative 8? It's negative 2. Okay? Now what I want you to do is I want you to take this exponent and divide by 3. Take that 9 and divide by 3. What do you get? Good. So that's x to the 3rd. Okay? So what I want you to look at with this x to the 3rd, we're taking the cubed root of x to the 9th. Okay? That means x times 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 x. Okay? Now I need a set of 3. Why a set of 3 instead of a set of 2? Because it's cubed. So if there's a set of 3 in there, I pull 1 out. Here's another set of 3 and another set of 3. So that is how I get my x to the 3rd. Okay. Can I go to nth roots? Okay, so second, which is a square root, and cubed roots are the most famous. They're the ones that you use the most often. But you can have an nth root. Other roots can be found as well. The nth root of A is defined as the nth root of A. If B, and you're looking for what value of B raised to that power is going to give you that A. So you're looking for the 4th root, the 5th root. And this is super important. If the index n is even, the root is not a real number when it's negative. So what you need to know about this right here, if the index is even, okay, so if n is even, it's not a real number. So because we don't know how I works yet, and we haven't explored I, then if the index is even and you get a negative number, you can't have negative numbers in there. That means it's undefined. If a negative is inside the radical. Because we're not talking about imaginary numbers yet. It's not a real number. Remember, I is imaginary. I is not real. Okay? So the index, if it's even, that's the key part right there. If it's even, you cannot have a negative number inside the radical. Okay? And the radical is the same thing as a square root. It just covers any index. If the index is odd, the root will be a real number. So that means negatives, okay, inside radical. So very often students will look at a radical, they'll see there's a negative value in there, and they'll immediately say no solution, not thinking that it's a cubed root or 5th root or 7th root. Okay? So let's go to the next page. Can I go to the next page? Do you guys like this stuff better? Yeah, I thought you might. Everybody does. Everybody does. We do have to do simplifying with this and then equations with this. Then we loop back to the quadratic formula. But in general, students like it a little better. Okay. Now we know how to use our calculators. So for the sixth root of 64, what we're going to do is we're going to have 6. Then we're going to hit that second button on our calculator. Then we're going to have our caret top, and then we're going to put in the number 64. So your screen is going to look like 6, and then it's got like an X right here. Does it have an X right there? And then we've got 64. That's what your screen looks like, right? So what did you get? Good. Good. Now, is a negative okay right here? Okay, yes. Why? Good. Negative okay because index is odd. Okay, so let's talk about keystrokes. We're going to have 5, then we're going to have second, caret top. I want you to put the negative 32 in parentheses. You want to get into that habit. What do you get? Negative 2, good. Okay. This is no solution. What is going on? I'm hitting things all over the place today. There we go. Negative, not okay, because index is even. So the answer to this is no solution or not a real number. Okay, because remember, I is not real. I is imaginary. Okay. Can I go to the next screen? Okay. If n is an even positive integer, so if I've got a to the nth power, even if a is negative, as long as I'm raising a to this nth power, then I can take the nth root of that. So let's talk about what that would look like. So if I've got negative 4 squared, and I want to take the square root of that. Now remember, I don't have to have this 2 right here. I don't have to have it right there. But that's what a square root means. There's a 2 there. What this means is I've got to simplify this first. What's negative 4 squared? Negative 4 squared. So be sure it's positive 16. So if you put negative 4 into your calculator, be sure you've got that negative 4 in parentheses. Okay? Because if you do negative 4x squared, what's your calculator squaring? Just the 4. Oh, if these are calculator strokes, I'm sorry. This is the x to the second button on your calculator. Is that what it is, x to the second? Don't you have it? Okay. So here, I'm telling my calculator to square the negative and the 4. What am I telling my calculator to do here? Just the 4. Okay, so be careful with that. So this is going to be the square root of 16. And can I take the square root of 16? I can. And that's 4. Okay? Now, if n is odd, then I'm just taking the cubed root of something cubed. That's all I'm doing. So here, I would have something like negative 2 to the third power, and then I'm taking the third root, or the cubed root of that, and so it's going to be just negative 2. Okay, and let's look at what I mean by that right there. Okay. Okay. Can I move to this next screen?
What's that?
Okay. We got it? We're good? Okay. So, right here, I've got to square this first. Okay, square first. Square first. So then, when I square that, I end up with the square root of 16 because I'm squaring a negative number. And when I square a negative number, what do I get? A positive number. Okay? And so that's going to be our answer. Now, here we've got our fourth root and our fourth root. So our answer here is just going to be x minus 2. Okay? Here I've got fifth root or fifth power and fifth root. So it's going to be 2x minus 7. Okay? And this one we've already done. What is the square root of 25x squared? It's 5x, not 5x squared. Just 5x. Okay? Okay, last thing that we're going to do. We can plug values in to square root functions the same way that we've been plugging things in all along. Okay? So right now I've got f of x and I've got g of x. One is a square root and one's a cubed root. Okay? So all I'm going to do for this is I am going to plug 7 in where there's an x. So f of 7, I have to go to the f of x because I've got an f right here. That's why I have to go to the f of x. So I'm going to have the square root of 7 plus 2. What's the square root of 7? What's 7 plus 2? 9. And then what's the square root of 9? 3. Okay? I'm going to use function f again, okay, because I've got this f right here. That's why. And I'm going to plug 0 in. So I'm going to have the square root of 0 plus 2. Okay? Can I take the square root of 2? Can I take the square root of 2? I can take the square root of 2, but it's an irrational number, so I'd get a long slew of decimals. So the square root of 2 is the exact value. Okay, so you're going to leave it like this. This is our exact value. If you put it in your calculator, you would have to give me a decimal approximation, and I don't want a decimal approximation. I want it exact. Okay? Every once in a while, you'll have directions that say, find the decimal approximation. But in general, you're going to leave things exact. And next week, when we start simplifying radicals, that makes a big difference, okay? Okay. Now I'm focusing on G. I'm focusing on G. So I'm going to this function right here because this is G of x. So I'm going to plug in a 9. So I'm taking the cubed root of 9 minus 1. That's the same thing as the cubed root of 8. And what is the cubed root of 8? 2. Okay. Okay. The last one, I'm plugging G in. I'm going to the G of x. So I'm going to do the cubed root of 10 minus 1. What's 10 minus 1? 9. If I tried to find the cubed root of 9, I would get a decimal approximation. So I don't do that. I'm going to leave it as an exact value. Exact value. Exact value. Okay? Okay. Now, this is